All right, hello everybody and welcome back. We've got another video. Today we're going through extension 1, counting ordered selections as part of combinatorics. Before we start with the actual counting joke. What do you call a hen that counts her own eggs? A mathemachicken. Okay, let's go. So we're counting ordered selections. Now I should probably hook up my iPad. So counting an ordered selection is basically a systematic way that we can find the number of ways something can occur. Okay, now if I put this through, there we go. So again, I'll say it one more time, so counting ordered selections is basically, it's a systematic approach because it's going to be very difficult if we try to think of it off the top of our head. So we're going to find a systematic approach to finding the number of ways something can occur or something can be arranged. Okay, so first thing that we're going to talk about is we're going to talk about this multiplication principle. And it's a lot easier than it looks. So don't freak out by the way this is written with all these N's and R's and whatever. I will show you exactly what it means, and it's going to be quite simple. So basically, this multiplication principle is if there are R stages, the first stage can be chosen in N1 ways, the second in N2 ways, all the way to NR. The number of ways to choose is you just multiply however many ways you can change it per stage. Okay, so a very simple question here that where you'll start to see this multiplication principle kind of work out is, let's say, for example, how many different orders can be made at a restaurant? I didn't even spell entrees right. Entries. With 3 entrees, 4 mains, and 5 desserts. Well, how many different orders? Well, I can have, stage 1 is we have entrees, and there's 3 different options I've got. Stage 2 is going to be my mains, and I'm going to have 4 different options. And stage 3, sorry, I'm having a great time here. There's 5 desserts, so it's just basically 3 entrees, 4 mains, 5 desserts. Those are my 3 stages. So all I need to do is multiply them together. And sometimes I like to do, some people do boxes, I just do lines. Right, so there's 3 entrees, 4 mains, 5 desserts. Multiply that together, and I should have 60 different orders. Hopefully that makes a little bit of sense. Okay, now let's try some more kind of like that kind of idea. Now it says how many 4-digit numbers can be formed from odd numbers. So if I want 4-digit numbers, that means I have kind of 4 spaces in which numbers can go. Now, how many numbers are actually odd? 1, 3, 5, 7, 9. Hopefully you guys in extension 1 know what odd numbers are. So there's 5 options. Right, there's 5 odd numbers that I can use. So it's going to be, how many options will I have for the first? I have 5 options for the first. I have 5 options for the second number, 5 options for the third, and 5 options for the fourth. And so it's just going to be 5 to the power of 4. Okay, so hopefully that's making sense because I have 5 options per one. And so I just multiply all the way through for however many I can choose. Now, it says here, how many of those numbers contain at least 1 9? Now, with a question like this, I want you to be careful here. Whenever we start using this kind of phrasing, at least, it'll be easier to find, okay, how many if there was 1 9 or no 9s, basically. At least 1 9 is the same thing as saying not any 9s. So if the opposite of at least 1 9 is no 9s at all. Maybe I should just not any 9s. I'll just say no 9s. How about that? So thinking back to kind of probability and complementary events, it's kind of the same concept of saying contain at least 1 9. So what's the probability, or what's the number of ways I can get no 9s? So if there's no 9s, that means I can pick 1, 3, 5, 7. And that's it. I can't pick the 9. So in this case here, still picking with the odd numbers because this is a part B. I have 4 numbers, but now I can't pick 9. So it's going to be 4 times 4 times 4 times 4, because there's 4 options for each one I can pick. So that's no 9s, okay? So contain at least 1 9 is now going to be the total number, which was 5 to the 4 from the previous question from part A. So there's 5 to the 4 ways I can form 4-digit numbers from 5 numbers, so from odd numbers. But if I don't want the 9s, I'm going to take away all the options where there are 9s. So it's just take away 4 to the 4. And I'm not going to calculate what that is, but you can put that in your calculator. That's just going to be your answer there. Okay, now let's take a look at this one. In a race with 10 people, how many ways can the first people be placed? So that means there's 10 people, but I only care about the first 3 places. So again, I'm just going to do, if there's 3 places, I'm going to find the first 3. Now, how many options will I have for first place? I'm going to have 10 options. Okay, this is where factorial kind of starts to come in. Now, how many people will I have for the second option to come second? Because there's 9, third person, there's only 8. So in other words, 10 times 9 times 8, that equals to 720, if I'm not wrong. So there's 720 ways that we can arrange the first 3 out of 10 people. Okay, now that's kind of what we're getting at today. So we're going to talk about permutations. Okay, now permutations, that's exactly kind of what this last example was here. Okay, the first examples that we had here, these ones are a little bit more about just finding the number of different orders or finding how many different ways something can be done. Now, permutations is where we get a little bit more specific and we start talking about ordering a set, and it's without replacement. Okay, so that means kind of like in a race, whoever places first can't also place second in that race. Okay, it doesn't work. So permutation is arrangement of objects and you can't repeat anything. No repetition. So I'll write that down. Okay. And we've got this fancy notation here. It says NPR. Now, P is on your calculator. It will be kind of next to your multiplication, if I'm not wrong. Let me tell you exactly where it is. Your multiplication. Yeah, there you go. It's literally shift multiply. Okay, that's where your permutation is. Now, these letters mean a couple things. N is going to be your total that you're choosing from. Choosing from. Now this R down here, this R is the number that you choose. Or number that are chosen. And then your P is just kind of what your P is. And then let's try to actually figure this out. So we'll do the same question, but we're going to use this factorial notation, and we can double check it with the calculator to get our answer. So in a race with 10 people, how many ways can the first 3 people be placed? So again, same question, but the total number that we're choosing from, so in this case, N, there's a total of 10 people. And your R is going to be the number of people that are chosen. So in this case, we're choosing the first 3, so the R is going to be 3. So in other words, NPR should equal to N factorial, which is 10 factorial over N minus R. So that's N is 10 minus R is 3 factorial. And this is going to be 10 factorial, and 10 minus 3 is just going to be 7 factorial. So that's that. So in other words, it's going to be 10 times 9 times 8 times 7 times 6 times 5 times 4. Oh no. Times 4 times 3 times 2 times 1. All over 7 times 6 times 5 times 4 times 3 times 2 times 1. And so you can see here, all of that will cancel out, leaving us with just 10 times 9 times 8, which is exactly what we found up here. Now, why would you choose this way? Is because at some point, you can just put it in your calculator. You can literally just write 10, you go shift times to get P, and then go 3, and you'll get the answer. I don't know if you can see, probably not. 10P3. It's because I got the blur on. How about I turn the blur off for just, oh, you're going to see my room. You're going to see my room. It's fine. It is what it is. All right. So if you take a look here, you can just put that in your calculator just like that, and you'll get your answer. So that's why we kind of like permutations. And I'm just going to get rid of bye-bye to my room. Oh, blur. Okay. Now that that's kind of done, we get the same answer as before, 720. That's just showing you all the different ways that we can kind of calculate it. Now, here are a couple tips to deal with the more difficult questions. Okay, deal with the restrictions first. Okay, I can't stress this enough. These questions get quite hairy and quite disgusting. And so the easiest way to do this is to deal with all your restrictions first. So for example, I can say 8 people form 2 even lines. Bob stands only in the left line. Tim stands only in the right line, and Abby and Mia stand in the same line. So how many different ways can the 2 lines be formed? So let's start with the restriction. So let's talk about Bob. Okay. So basically we've got Bob. So B for Bob. How many different options do we have for Bob? So Bob only stands in the left line, and 2 even lines, that means we need 4 per line, right? So that means he's got 4 options in terms of where he can go on the left line, because there's 4 places. All right, let's take a look at Tim. Tim only stands in the right line. So again, in the right line, there's 4 places. So there's 4 different options where he can stand in the right line. Okay, now let's have a think here. If we've done Bob, we've done Tim, let's think about Abby. Okay, now Abby, if Bob and Tim are standing on one on each side, there's actually going to be 6 places left where they can fit. Okay, so Bob's taken 1 space on the left, Tim's taken 1 space on the right. Abby has 6 options. So I'm just going to go, Abby has 6 options. Now, if Abby goes with, if Mia goes with Abby, technically Mia only really has 2 options, right? So because that'll be 3, Abby and Mia can switch. So they can kind of switch together, but wherever Abby is, that's where Mia follows. There's only 2 spots that Mia can go once Abby joins either Bob or Tim. Okay, there's only 2 spaces that Mia can join. Now, once we've done that, we've only picked the first 4. And there's 4 more people, 4 more randoms that can join the line. Okay. So those are the restrictions. There's still another 4 people. Now, how can those 4 people be arranged? Well, they're not fussy. They don't put restrictions on us. So the rest of them is just going to be 4 factorial. So that means 4 times 3 times 2 times 1. And so to answer this would just be 4 times 6 times 2 times 4 factorial. And again, you can put that in your calculator to figure it out. Hopefully that makes sense. And that's it for today. Hope you guys have fun doing this. It's a bit tricky, but just remember, deal with the restrictions first. And you're going to have to think a little bit logically about how we go about answering this. All right, I'll catch you later, and I'll see you. Bye.